Good morning, everyone. It's time to start our second EASA AI days actually, and that's day number 2, dedicated to the MLEAP Stakeholders Day. You will learn a lot more about what MLIP means and is. It's a research project that we started from EASA side on machine learning application approval. You will learn really a lot about it today. So yesterday, we had actually a very nice day. Everyone fed back a lot of good feedback from the first day. So I am Guillaume Soudin, AI Program Manager at EASA. Yesterday we had the opportunity to unveil the roadmap 2.0 and all details, I would say, around, and engage in discussions also with numerous stakeholders present on site, but also online through various Q&A sessions. You can see the participation on site was really great. We had a very good day, nice weather, nice evenings as well together. And as I mentioned, we got a lot of very good feedback. I got also through the discussions one erratum that I wanted to bring forward from day number 1. We had on the slide, the last slide presented by Alain Leroy on the timeline of the roadmap, an indication of the level 2A being pushed to 2035. Actually, that's not the message we were passing. This should have been probably written 2B. 2B is the level we are pushing to 2035, and 2A will happen somewhere between 2025, 2035. So we will correct that on the slides that we will put online. Sorry for the confusion on the slide. Actually, the message on that slide, as you could see yesterday, was about level 3. So Alain pushed his message really on level 3 is more the thing that we have to push a bit further. So that's important to pass this message to everyone that definitely 2B for 2035, 2A will happen with 1B, by the way, somewhere in between 2025, 2035. So that's really important. And let's kick off this day. So I pass the floor to Mathieu Rochambeau, who will be from Airbus Protect, who will be our master of ceremony today. Thank you.
Thank you, Guillaume. Okay, so good morning and welcome everyone to the MLEAP Stakeholders Day number 2. We are here today at the EASA headquarters in Cologne. So my name is Mathieu Rochambeau, working at Airbus Protect. I'm the communication task owner in this project, and I will be the moderator of this session. So first of all, thank you all attendees for joining either physically or virtually. I see that there is a lot of you who are already connected and as well as with us in the room. Before we get started, I'd like to point out that this event is recorded and the replay will be available on our YouTube channel at Airbus Protect. Okay, so thank you, EASA, for having us here today for this great event. Thank you also for making us a part of this great day. And I would like to point out the fact that thank you for the confidence you have given us in this project. Today was a great day. We all are thrilled to be here today for this event that will end today, right after our conference. Today was a great day, so let's try to keep it this way for today. So I will now present how the event will unfold. So we'll start in a few minutes with the introduction of the MLIP project partners, the introduction of the MLIP project, and then we will go on with the presentation of the use case and the single public deliverable. Then we'll have a Q&A session and a short coffee break. Then we will continue with the presentation of the task 1, 2, and 3. We will have a conclusion and the next step, and then we will end this two-day event with the networking lunch. So like we did yesterday, we have food and beverages that will be available for you at the end of the session. You are more than welcome to stay with us as well to keep the party going and keep exchanging with the consortium members as well. And so if some questions could not be answered today during the conference, that will be the time also to answer them directly to the team and the consortium members. Okay. So last but not least, like yesterday, we will use Slido for the Q&A session. So just scan the QR code with your phone and then type the questions within the application, and Ines and I will manage that. And thank you, Ines, for that. Okay, so here today on the other side we have, and I will let you introduce yourselves as well.
Thank you. So Guillaume Soudin, again, EASA AI Program Manager. For the MLIP project, I am a sponsor of the project. And I'm accompanied here. Actually, Willy Ziegel is our project manager for the project. He could not make it here today, but we have the other colleagues working in the different tasks. So François, if you want to introduce yourself.
François Triboulet, seconded to EASA. I am an ATM&S expert with regards to the AI program. So I am the project leader for what we call the AI assurance. So everything that is related to the implementation of the W-shaped cycles, including explainability and so on, explainability in development. And for later looking at other technologies like reinforcement learning, hybrid AI, and so on. My role in the MLIP project is focusing on the task 1, so dealing with data management and data completeness and data representativeness.
Good morning, everyone. My name is Xavier Henriquel. I'm a safety assessment expert in EASA. I am the technical leader on EASA side for this project. I'm also the focal point for the task number 2 related to generalization guarantee. I've been working on the EASA AI roadmap from the beginning, and this project is one of our key projects at the moment to progress on the means of compliance.
Hi everyone, my name is Tizé Belkacem. I'm a data scientist from Airbus Protect, and my role in the project, I'm a technical advisor, and I'm working with Jean-Baptiste and Jeremy Bascon, who is not here today, on the task 2 about generalization of machine learning models.
Hello, I'm Olivier Galibert from the National Testing and Metrology Laboratory, which I will talk about it a little later. And I'm the technical leader on the consortium side for this project.
Olivier, you can introduce the company right now.
Okay, as you wish. The LNE is over 120-year-old, well, we could say company, but it's a public company. And we are dedicated to testing everything that's used for consumers of our industry to see whether they correspond to regulation or to certification and things like that. And the AI team was created in 2008 at the request of the Ministry of Defense in France to start testing in the domain of AI in general, because there was a need that was growing in that area. And since then we expanded a lot, and not only we are testing systems, but we are working on normalization, on certifications, on all these kind of questions, everything that makes AI acceptable for actual use for institutions and for everyone, more or less. So that's why we are dedicated to that. And in this project, as LNE, we work more on the data aspects, data management aspects. But since we're technical leader too, we help a little with everything.
So hi everyone, I'm Arnaud Yolalen, I'm the CEO of Numalis. Today I'm also accompanied by Noémie Rodriguez, which is a data scientist and project coordinator for Numalis on the MLEAP project. Numalis is a SME working on reliability of AI systems. Basically our key differentiator is that we want to assess reliability using only formal methods, which is kind of the on point for the aeronautic industry, and so we adapted the current formal methodologies to machine learning systems. And since all of this is rather new for the industry, we're also heavily involved in standardization, mainly at the ISO subcommittee on AI, but also more recently on the SENSENELEC subcommittee regarding the implementation of the harmonized standards for the AI Act that was explained just yesterday. So we're, like I said, a small company, well, 20%, but we are working on many European projects, both in defense, through EDIDP project, but also in aerospace, obviously in aeronautic with MLIP, but we're also involved in healthcare and railway. And basically we developed a solution that is a SaaS solution that helps AI engineers to measure both robustness and some part of explainability of AI system. And I will talk more later about the robustness part, which is the task where we have in charge for the MLIP project.
Good morning, everyone. I am Michel Kaczmarek, the project manager of the consortium, and I will introduce you quickly Airbus Protect. Airbus Protect is an Airbus subsidiary created on 1st July 2022. Airbus Protect is the merging of Apsys and Airbus Cybersecurity Services. We are a risk management company which aim to offer end-to-end advisory, consulting services, training programs and software solutions in 3 areas: safety, sustainability and cybersecurity. We have more than 35 years of experience in industry-leading expertise to deliver services. Today we are more than 1,400 experts in France and across Europe. Thank you.
Hello, my name is Jean-Baptiste Rouffet. I'm from Airbus Protect, and I am the task owner of the task 2, which is dealing with generalization guarantees.
Hi everyone, I'm Sven Ribeiro. I'm a research engineer at LNE, and I'm also the owner of Task 1 on the MLIP project.
It seems we have a small technical issue on the WebEx where they get an echo. We will try to sort that before going further. Is the echo still there? Can someone say on the WebEx, please? So let's wait. I think the problem is we have this and this connected, so let's have a look. No, but it's not the mics, it's the, I think, the 2 computers here. So we'll have to get someone sorting this out. Sorry about that. Technical live issues. It's because we have 2 mics, probably. Technical service. No, I think the media technician is coming in a minute. Yeah, people on the WebEx say we can go on. Let's take just a minute to try to sort it out, and if not, we will definitely carry on. Yeah, thank you. Okay, yes, so let's go ahead. I see a lot of signs from the WebEx that we can do. So let's go, and we will, when the media technician is there, we will try to arrange that. He's here. Great, yeah. Let's make it more comfortable then. They get a metallic sound on the WebEx. Everyone on the WebEx. So I suspect this is because we have this mic still open. So what can we do to find out the source?
I don't know if I can do anything about it.
Maybe you can connect to the WebEx and have a check if it works. And then, so we will go on. Sorry about that. It's difficult to sort the issue out for now, and let's carry on with the presentation. Thank you.
Well, I will now give you back the floor, Xavier and Guillaume, for the introduction of the MLIP project. Okay.
Thank you. Yes, so the team has been already introduced. So we are 3 people in EASA working in the project, in the MLIP project. Here you can see a reminder, I would say, of what we discussed yesterday. So from the top, for people maybe joining only today, also online, the EASA has published a roadmap 2.0 to update the strategy on AI. Of course, the strategy is still towards AI trustworthiness. That's our big message, main objective, I would say, at the top of the list in the roadmap, in the AI roadmap from EASA. What we did with this roadmap, we further did an impact analysis on all aviation domains. So that's a large impact. That's one of the things we need to manage, and that explains also all the steps we are taking in a coordinated way with all domains, finding use cases in every domain, but also anticipating the rulemaking necessary, as was presented yesterday by Michael Gerhardt. We found a common issues, actually a set of common challenges and issues for all domains, as long as we are entering safety-related or safety-critical applications. And therefore, we have created this notion of, or this at least framework, proposed framework for AI trustworthiness as a concept that is the key factor for developing everything we do then in the deliverables of the roadmap, which are taking form of those AI concept papers that you could see published over time since 2021. So in 2021, we published the first concept paper for level 1 being human assistance, pure assistance, I would say, to the human. And in 2023, earlier this year, we published a concept paper, proposed issue 2, which encompass an extension of the initial guidance for taking into account what we call level 2 applications, meaning applications of possibly still assistance, but bringing the assistance one level beyond at a level called human AI teaming. And this is something that is really very important. The foundational part, let's say, of the AI assurance and learning assurance has not evolved in concepts and principles. That's still embedded in this notion of learning assurance and, as François reminded, development explainability. And this is something on which MLIP is actually intervening in order to provide compelling means of compliance for tough objectives and challenging objectives of the framework that was laid down. MLIP's timeline, you can see it here, but Xavier will go in more details on that aspect. On the side of the guidance, so as said, we are at the level 2, so 1 and 2 have been aggregated in one document, this proposed issue 2. It was published for public consultation earlier this year, so the consultation phase has ended. We have received a number of comments which will help us maturing further the document. Every publication we have, the roadmap, of course, the concept papers, any related documents like IPC reports or a link and the MLIP project or a link to the MLIP page. You can all find this on the EASA page dedicated to AI, which is the EASA Europa EU/AI. And that's important that you can follow up also the next publications from there. In terms of trustworthiness of AI and the concept around it, we have tailored it in 4 building blocks, the trustworthy AI building blocks. First, an AI trustworthiness analysis, which aggregates characterization of the system, safety and information security analysis. We always say the principles are not changing on that side, but yet we have to adapt to specificities of AI techniques. And then we have the novel type of assessment, which is the ethics-based assessment. So we discussed about that yesterday. Everyone interested and not participating yesterday can watch the video when we put it online on the event site next week. In terms then of more technical building blocks, we have the AI assurance, which used to be called learning assurance in a previous version, so don't be mistaken, it's still the same, yet we want to encompass larger amount and scope of techniques as presented also yesterday with the roadmap 2.0, and this is where we generalized, I would say, the notion of assurance to the AI, a bit more larger to encompass those other techniques like symbolic or hybrid type of AI. The learning assurance is still a building block, an important building block within the AI assurance, together with the development explainability. Another building block has expanded in scope. It's the human factors for AI. We discussed it also yesterday. It's a new layer of guidance, additionally, to deal with the challenges of human AI teaming at various levels, and we talked about 2A, 2B yesterday. AI safety risk mitigation is a crucial and very important building block, really dealing with the safety risk on innovative and disruptive aspects of the technology. It's, as I said yesterday, underdeveloped at this stage, but definitely moving towards 2B concretely with use cases, but also level 3, more, let's say, advanced automation. We definitely will have to reinforce this building block. So it's a bit of a stepwise approach where we reinforce progressively and sometimes expand the scope of the building blocks. The work today that has been done with the MLIP project and the scope of the discussions today will definitely focus on the AI assurance block. That's why I've put this frame around. That's the core of the discussion for today. In terms of challenges remaining, we have many more than 3, but the top 3 are still to anticipate, first, to anticipate means of compliance for learning assurance objectives on model guarantees. So generalization and robustness are high on the radar, therefore very well represented in the tender we published for the MLIP. But we had also at the root some concerns as well about the capacity to provide completeness, representativeness on data sets. And you will see it doesn't have to be always an issue, but when you go for high dimensionality, it can be a very huge concern. And this is one of the big reasons, let's say, to starting MLIP. And also here, we can say that the focus of the discussion today are on this exploitation, I would say, of the results from the MLIP project that will be fed then into the AI concept papers on EASA side. Yet we have other challenges that are a bit out of scope for today, but it's important to mention. Operational explainability, guidance, and human-centric aspects of AI in this human factors for AI building block are another layer of concern, challenges, things we will have to go in more details. So we will definitely engage in more projects on those aspects, as well as on the third objective, which we have put also high on the radar, ethics-based assessment. Societal aspects of this analysis and assessment are challenging, for sure. It's something that is pretty novel in our field of aviation to take into account to such an extent. And we will have to evaluate and refine guidance based on use cases on that end. Okay, so for today, a zoom on learning assurance. And learning assurance today is oriented by this W-shaped process and let's say framework, let's call it a framework. So it organizes the guidance in specific blocks that are meant to make an evolution, I would say, from traditional development assurance principles we know for systems, software, hardware, into something that is dedicated for a start to machine learning. We will expand this view again to other techniques in the near future. For now, it's extremely focused on machine and deep learning. At the top, above the dotted line, we are still in a, let's say, development assurance framework completely with capture of requirements, validation, verification principles, all the principles of development assurance fully apply. So we will just keep an eye, let's say, on the, not only an eye, we will keep the existing standards working. All the existing requirements and guidance don't have to be modified, but we need for sure to interface with another layer, which is below the dotted line, where we start having data management, for instance, but probably knowledge management when we move a bit further. We hit a place where a specification is not anymore a set of requirements that are captured either in textual form or in a model. It starts to be the data actually that bear the specification. And that's something we have to take into account, deal with from the start. before even entering the learning process management, which is another huge step on the way. Before pressing a button, let's say, to enable a model training. Sounds simple, but it's also a very important step with a number of cautions to take. And we come into a first verification step, the learning process verification, in a first V, I would say, that creates this W shape, because we already go up, try to verify this first phase of the first descending V, which will happen in a very iterative way. You have some pictures in the concept paper showing a lot of feedback loops and arrows. That's very important to say. This part of the work, let's say, is the novel part and is very iterative. When we have a model, a trained model, that is satisfying a certain level of performance, guarantees, etc., from this learning process verification, we can enter in a more traditional V, I would say, in model implementation, to come up with an inference model, the one that will be embedded, either on, let's say, really embedded in an aircraft or in a system deployed, but at least the one that will be used for the inference in operations. This model implementation, and you can see at the bottom, the two yellow boxes are definitely saying for software, hardware implementation, we don't change anything. We will use the existing standards in all the domains related. And this implementation has a less novel touch, yet we have to verify a lot of things. Cautions have to be taken to be sure that this translation of the trained model to inference model is well prepared and well done. And then we go up in a more traditional way of integrating, verifying on the way up to the system with an independent data and learning verification step that is also another important layer added compared to previous approaches for machine learning. And if we now move to, to just a view of where MLIP stands in this W shape, you can see the different tasks here. So the data management definitely is embedded in task 1. You will see a lot more details later on. The learning process management, task 2, and task 2 goes also in verification, I would say, and independent data and learning verification. And we have the MLEAP task 3 that is distributed really for the robustness of models, another important property along the line of the different verification steps. So with that, you have a context, I would say, to start the day and understand where we start from at EASA side, on EASA side, from the guidance, to say here we have a couple of challenges to sort out, and MLIP is a huge and important project for doing that. And I pass the floor to you, Xavier.
Thank you, Guillaume. So yes, really at the genesis of MLIP, Machine Learning Application Approval Project, was this need to identify concrete means of compliance with the learning assurance objective of the EASA concept paper, of the EASA guidance. And at the end of 2021, we identified this opportunity to have a research project funded by EU Horizon Europe. A tender was launched, and after a selection process, a consortium led by Airbus Protect with LNE and Numalis was appointed for a 2 years time period. So what is the MLIP project about? We have 3 technical axes that are meant to help us pave the way for future approval. The first technical axis has to do with data completeness and representativeness. The second technical axis is with regard to model generalization guarantee. And the third technical aspect is related to algorithm stability and model robustness. So why did we selected this first task on data completeness and representativeness? Well, first of all, data in general and data quality is a challenge in terms of cost, and we wanted to focus on the aspect that was of a higher priority for the industry. And why data completeness and representativeness? Well, at the time, we had some challenges identifying some dedicated tools to serve as a means of compliance, dedicated method. So we thought it would be a good idea to investigate in this area. And beyond that, for data completeness and representativeness, we have particular challenges. And one of them is a trade-off between representativity and diversity. Diversity being the fact that some rare cases may have to be augmented so that they are properly modeled by by the model. Looking at so that was the first task. For the second task, we are looking at generalization guarantee, meaning that the model may perform well on training data, but we also want it to perform well on unseen data, especially when it comes to safety critical applications. So this task is really aimed at defining strategy, protocols, so as to ensure that the release model will generalize as best as we can, bearing in mind when we define this protocol and strategies that there is a side effect, there is an effect on the data quality requirements, on the volume of data that is needed, and for the most critical application, we have some objectives that requires to have some assessment or to quantify how well the model will generalize so that we can tie this to the overall safety case. The third technical axis for this project is related to robustness. So algorithm learning stability or model robustness. The first point we wanted to focus this task on was to assess the various concepts and definitions, so as to make sure that, so as to validate and mature our own definition in the EASA concept paper. So what we've done is we've looked at what we've done in the past in the CODAN IPCs, what we had in the EASA concept paper, and what is happening in the ISO, and we are comparing and looking at the definition to mature the framework and the concepts for robustness. That's one thing we've been doing in the last few months, and it's already done, and you will know a lot more about it in the follow-up presentation. Then a reason why we look at robustness on this project is that there are a large variety of methods that are available, from empirical methods that are mainly based on observation, expert judgment, to statistical method where a statistical test is done and a result can be achieved with certain, and then we get mathematical proof that a certain result can be achieved with some confidence, to the formal methods where a formal demonstration is done and then the property is formally demonstrated on a given space. Formal methods are a topic of particular attention. They seem to work well on low dimension use cases, but in MLIP we wanted to push this further and start looking at high dimension cases. And this investigation of formal method is something that we've also been doing in another project, in the EASA Collins Formula IPC that was mentioned yesterday already, and that was finalized a couple of weeks ago, and the report is also already online. And we will be looking at this, at the outcome of this project in the coming phase for MLIP. Beyond this three technical tasks, this MLIP project is also helping us for future approval in a certain number of aspects. It's the first opportunity we have to work on, to get hands-on AI, ML, aviation use cases. We have a direct access. We'll have a direct access for this project on detailed models, on data sets. So it's quite important for us to help us in EASA familiarize ourselves with the design activity. It's also a good opportunity to develop or to highlight some public data, some example, and to have some result to achieve some result on this public data, so that interested third parties can compare their own result or their own methods with what we are doing in MLIP. Obviously, we have some, like for any research project, we are going to share the knowledge we are acquiring through this project through events like this one. There will be one every 6 months. We have a project page where we are posting our latest result, and you can subscribe to it, and so that you receive any update that we are making. Public reports are being posted. and we will regularly update the EASA concept paper with MLIP's results. The main results will be implemented at the end of the project in the issue 3 of the concept paper, but issue 2 already benefits on some aspects, on some definitions from the work being done in MLIP. And just to finish with the MLIP project presentation, this project is one of the EASA AI program projects. It's running in parallel for 2 years. We are running during the phase 1 and phase 2 when AI concept papers are being developed. So MLIP is feeding these concept papers. 2 main milestones, one a couple of days ago with the release of the first public report. It's available on our website. And the last milestone, the second milestone, is the final public report publication in 2024. Each time we will organize some dissemination events, and we will have some stakeholders days in between every 6 months to keep the community up to date on our progress, results, and acquire some feedback. So I will now leave it to you.
Thank you. So as previously mentioned, we are focusing on 3 main use cases in order to implement select methods for the different evaluation activities of the MLIP project. So the objective of these use cases is first to lead and support the methods and tools selection, and also perform a qualitative evaluation and experimental based evaluation and comparison of the different methods in terms of data qualification, model evaluation, and also the performance verification after the model's training. And then finally help making the recommendations and suggestions for possible means and compliance on these different aspects. So the 3 main use cases are different from the point of view of data complexity, data dimensionality, and the task complexity. So the first one is based on automatic speech recognition application, is the speech-to-text translation for air traffic control, and the second one is a vision application. It is automated visual inspection, and the third one is the ECA6U, so the well-known collision avoidance system. So let's start presenting the first use case. As I said, the air traffic control and speech-to-text. So the main objective of every automatic speech recognition application is to go from the speech input signal and output recognized words structured in correct sentences. The main objective is to understand all the spoken instructions and the spoken words and correctly reproduce the corresponding text. As for these application on the air traffic control domain, so based on the state of the art, we identified 3 main objectives. The first one is the language understanding. The second one is the spoken instructions understanding, which we are focusing more on this project. And the third one, the voice print recognition, or the recognition of the speaker based on the input signal. So talking about these different applications implies a set of issues and problems that we need to deal with. The first one is based on the production mechanism, which means that we have to handle the different noise and intelligibility, the speech rate, and also the differences between the different equipments used to input to the speech signal. And the second one is a set of problems related to the language and accent, mainly the multilingual and also the different spoken English accents. So which means that on this use case we are mainly using the speech input that corresponds to English instructions and using different accents. So as for the models and data, We are provided with two different kind of data and models. So we are, as part, using Airbus internal projects that provided us with data and implemented models that are under the development, evaluation, and training. So on the right image, so we try to translate the system that has been developed by the internal project of Airbus, describing the main configuration of the different parts of the system concerning the construction of the data set, and also the translation of the input speech signal into a set of features until their cognition of the spoken words. And the second part concerns the use of open source data and models. And as we said, we aim to publish results and also evaluation pipeline for the different use cases. That's why we meant to use so Airbus internal project resources and also open source data and models for the sharing purpose. So based on both the data sets, as I said, we have the recorded utterances provided with the correct text transcriptions using different kinds of accents, mainly English, French, and German accents, in addition to other accents that are present on the open source data. As for the models, so the Airbus models are based on machine learning models implemented without deep learning neural networks as a first step, implemented using CalD and also VOSC APIs. As for the open source models, so we choose the deep learning models based on transformers to make a comparative so to show comparative results based on the two different models, machine learning and deep learning. And finally, concerning the challenges that we are addressing on the MLIP project for this use case, we focus on the correctness of the translations as a first step, concerning the robustness towards different kinds of noise and accents that are present in the data sets. And also, as a second step, we will evaluate also the call sign detection and also the detection automatically of the spoken English accent. The second data set, the second use case, as I said, it is a visual inspection. So the objective of this use case is to help the operators to perform the in-service damage detection. So this is an objective based on the, as I said, the internal Airbus project. And also the open source data set and models are under investigation. On this use case, so we have as input a set of images and videos, and the objective is to correctly detect if there is a damage on the skin of the aircraft, and then perform the automatic detection of which kind of this damage it is. So is it a lightning strike or the dent impacts? So we put here some details about the data sets and the models. So the models are still under development, and they are all based on CMS networks developed with open source frameworks. And we aim also to make a comparison between deep learning and machine learning models using the different APIs. Another detail is that this concerning this use case, the project is still under development. So one of the important challenges for the MLIP project using this use case is to perform the qualitative evaluation concerning the detection of the different damages and the correctness of the classification of the detected impact. And also target the first performance of 95% of accuracy concerning the correctness of the damages detection. So as for the last use case,
So the third use case is called the AK6U. So AK6U is a variant of AK6 system, which is a universal anti-collision system. This system is based as soon as two aircraft are entering in the same flying zone. The system is proposing trajectories that avoid all possibilities of collisions. To do so, the initial systems is based on lookup table. Those tables are calculated by the MIT. And we take as input different information concerning the position of the aircraft, such as the distance between the two aircraft, the relative angles, the speed, and also the last instruction that has been proposed by the system. Then, based on the lookup table, we have instructions such as clearance, so meaning no change in the trajectory, weak right or weak left to change the trajectory, and the strong right and strong left for the trajectory. The use case we will use here aim to replace the lookup table by neural network. Based on this approach, we can compress a bit the volume of data that should be onboarded in the aircraft or in the flying object. But in the opposite, we have also an issue because we need to guarantee full alignment between the output of the different neural networks and the lookup table results. So it's important to this use case for us because we have here several neural networks which are working in parallel, and we'll be able to test our proposed means of compliance to check the guarantees, the representativeness, and so on, based on the specific system where we have a monitoring which identify which neural network should be activated depending on the input parameter. And we have also a full ODD, so operational design domain, which is known, so that will help us also to have the truth concerning the expected result, and then to be able to compare the result of the neural network versus the reality. So it will be a key for us, again, to check if what we are predicting with the different performance evaluation tools that we will use is correct or not, and what is the level of uncertainty we could have versus those approaches.
Okay, time for you, Olivier, for the MLIP report.
So, hello. We had the pleasure of releasing the first version of our report last Thursday, I think. There will be a second and final version in a year, and it's a nice 260 pages document. So I know some people have already read it from beginning to end. I'm impressed, I must say. I wouldn't have expected to happen that fast, but I hope you liked it. So I'm here to give you an idea of what's in there, not in the details, but the general idea of what you're going to find it. So it's organized around 3 topics that mostly, but not entirely, matches the task Xavier already presented before, but we decided to ignore a little the task when we created the document to make it more usable outside of the project. So the first topic is data. We all know data is important when you create machine learning models. So we emphasize on the question of representativeness and completeness of the data, and what it means and how it interacts one with the other, and how it interacts with the other properties of all that. And also on the corner cases and outliers, which is an interesting question because a corner case is not necessarily always outside of the ODD, but it can be between classification, between classes, and things like that. So it's an interesting problem. The second topic is models. I think that goes and in particular an emphasis on generalization properties, how to right-size your model. You don't want it too big, you don't want it too small, depending on the data you have. On how do you look if the generalization targets were accomplished with your training, all these kind of questions. And the last point is on the evaluation. In the evaluation, there's the basic things, we could say, where you just test your model on a number of examples to see how it goes, but there's also a question of, is it stable on your data, and how can you evaluate that, and what can you do at deployment time to see if the model is still working correctly, or at least is still robust. The questions like that, including all the interesting things you can find with analytic and formal methods when you're studying models in white boxes. So these are the 3 topics of the document. And on each of these topics, we follow more or less the same methodology with just different timelines depending on the topic and the organization of the project. The first one that we all did already is the definitions, because I've been using terms, but what they mean depends, and mostly depends on what document you're looking at, between ISO, between the concept paper, between even Codan and things like that. We don't really have an agreement of even what an ODD means. So we decided to present the different definitions we could find of the terms that are useful in our work, and in the introduction show what definition we choose to use, and we follow the CP of course, usually, to define what we are actually doing in the document. So only for the reference of what terms are used for what, I think the document is useful, because this is something we don't have clarity in the domain for now. Then the second step is the state of the art, which is a review of scientific literature to find existing methods and tools to try to achieve the targets we were talking before, of generalization, of representativeness, etc. Once all these accounted for, we could say, we build selection weights to associate if you have that kind of data, if you have that kind of question, that kind of model you want to do, what methods, what processes, what tools are you going to be able to use to try to validate at least that you've reached the targets you have in the ODD. The advance in the selection grid depends on the topic. It's more advanced in data for now, and it's being worked on the other 2 topics. Then comes little in parallel comes the experimentation, because it's nice to find methods and tools in scientific literature, but the reality of when you want to use them is maybe something different entirely sometimes. So a large part of our work, and one we are really working on right now, is trying to test these methods and test these tools to see how actually usable they are, how actually efficient they are, if they scale, if all these kind of questions. When you have to do something pragmatic, you have real systems, you have real data to work on. What can you effectively do with the tools you have? So we experiment with scaling, and eventually we're going to try with the aviation use case that Thierry and Jean-Baptiste presented just before. But right now we use whatever data, whatever models we can find, if they're useful to show things about the methods and the tools. The idea is really to have a real pragmatic experience of how usable they are, so that you, all people, can use them or not when you have to. And something that also happens in parallel, and it's very well advanced in the model aspect, is projecting all that on the W-shaped process, because the idea of MLIP is to make actionable, pragmatic choices, methods, tools to actually implement the W-shaped models in the case of the AI assurance aspects we're interested in. So we try to project all of these on the process to get an idea of what it means pragmatically, and generalize the methodology as much as reasonably possible. And it ends up structuring the inputs so that the EASA can use them in their own documents and their own processes, and they can pick and choose what they want to actually make relevant for aviation habilitation. So that's the steps we follow in all the topics in the document. So right now, There are 6 chapters, the introduction with all the definition, the presentation of use cases, and then 1 chapter for each of the topics, and the conclusion. Before the introduction, there's even an executive summary so that you can have an idea of what's in the document. So there are mostly 3 ways to read the document. You can read the executive summary and stop there, give you an idea of what's there. You can read all the introduction and conclusions you have on each chapter to get an idea of what's in each chapter, and then you can read the chapter themselves when you have the time and the inclination to have all the information for the different things. So we try to make it accessible that way. You can choose the level at which you want to read. And then where do we go from there? Well, it's the intermediate report, so it's far from complete. So we are going to complete the selection grids. We are going to complete the experimentation so that we have an idea of what tools we actually can use. Then we're going to apply all these methods to the use cases so that we change the point of view. We don't test the method, we test, we have a use cases, does the selection grids work? Does the tools work for that use case? Then we are going to consolidate the projection to a U-shaped process. And the important part, we want to listen to the feedback from all of you when we are now discovering this document. So send us emails. We are going to take them into account. We already got some, and we love that. Please continue.
Okay, so thank you for this presentation. So we're going to take a few questions. So if you haven't asked the question, use the QR code and use the Slido application to do so.
Good morning again, everybody. So we're just checking the questions, and maybe we start with a particular one in Slido. Please continue introducing your doubts, comments, and questions. They are all welcome. Yeah. So it will be also interesting if you point out the person or the presenter that you want to reply directly to your question. This would also help. So the first question goes like this. Hello, for the MLIP, it is planned also to consider cybersecurity in this study, security assurance level.
Well, we have really focused on data representativeness, completeness, cybersecurity, and the 3 axes we explained, generalization, guarantee, and robustness. It's already a lot to do. So cybersecurity is not within the scope of MLIP. We have some dedicated section in the EASA concept paper already. It has been significantly improved at issue 2, thanks to the work of François. It's been submitted to public consultation, this section, and we will look at the comments and improve this part. If there are follow-up research projects where we can look at AI and develop further the means of compliance, it may be an aspect we look at. But for the time being, I would say that we already have some proposed means of compliance in this area, and we don't anticipate to work to develop further on that.
Thank you, Xavier. Second question, it says currently, yes. Oh, sorry. So we have another colleague that would like to comment. Yeah, François.
So yes, indeed. So it is not part of the scope of the MLIP project. However, there are some additional information in the second issue of the concept paper. Recently, we received some additional reports on what is the progress specifically in cybersecurity with regards to all the threats that will be really focusing on machine learning. So we will investigate all these reports so that we can probably already complement some aspects in the final version of the issue 2 or at least in the issue 3 of the concept paper.
Okay, thank you. So the following question goes like this. Currently, it seems that any AI-based research and development initiative, for example, the speech recognition of pilot ATC radio communications, requires a very costly private project, usually unfeasible for small organizations, to gather the necessary data. Is there any European level initiative to build and share such data sets? You have to, mic on, very well.
Yeah, that's a very good question. We had question in the same area yesterday about whether typically EASA would invest or would go into the direction of developing data set. It's not a direction we've taken at this stage, neither for the MLIP project nor for the EASA roadmap. We are focusing in MLIP our resources on improving the means of compliance. And when it comes to European level initiative, well, I can only answer for EASA, but maybe Guillaume, you have more visibility?
Guillaume?
Yes, with pleasure. No, just to complement, I fully agree with what you said, Xavier. As I said yesterday, we will welcome and accompany any initiative from the community to get in that direction, but it's definitely not something we can do from EASA alone. We have a number of, let's say, initiatives already started, like the Data for Safety program, which is aggregating a number of data which in the past were scarce and spread around and are now managed in a centralized way with anonymized data at the right level. So Leopold Viroles is unfortunately not with us today. He could tell a lot more about that, the program manager within EASA about data for safety. But that's one example in which we could at some point consider usage of available database, data lakes, in order to promote even more the safety of the development of AI applications. But definitely at this stage, we have not put it in our roadmap as a direct priority and path, because it's something that needs to be seen also from the community. There will hopefully be initiatives in this direction. This is not something we have right away to propose to SMEs or smaller companies. Thanks.
Thank you, Guillaume. Very well. The following one says, for me, I believe it is disproportionate to make it mandatory for formal methods and other high burden evidence against a classification level 1 and a minor safety classification. What is your view on this? Who wants to reply? Yes, please.
So I guess the main answer I could say is that it all depends obviously on the level of risks. When we use formal methods, usually in aeronautic, it's for high critical components, not necessarily for the entertainment software within the plane. So obviously the view of using such method has to be proportionate with the risk of the AI system that needs to be validated. The only counterpoint I can make is that even if not applied fully and all, for example, on all the space of the input space, formal methods can also bring value during the design in order to detect potential problems and improve the design and save time, basically. So the fact that it would be mandatory, it's up to the EASA. It's not up to Numalis to say that. But I would think that it would be proportionate to the level of risk of the component.
Guillaume, do you want to comment? Let's see.
Yes, just to complement quickly the answer, I'm also working in the task 3 with Arnaud and the rest of the team. Definitely from EASA side, we have absolutely no intention to make a prescriptive usage of certain means of compliance. What we are trying to open with MLIP is definitely the floor to all possible methods. First, to verify together that there is no objective that is kind of unreachable. That's the first scope. Then with those methods, as was reminded by Arnaud and Olivier in his presentation, we will have a panel of possibilities which we will open. If it's of course already in the standard, then it will not be in the regulations or in the AMCs from EASA. If there is something to complement, we will do so through the AMC material we will prepare. But none of the AMC material is prescriptive and mandatory. The word mandatory doesn't apply to this level of regulations. Even the CS is still soft law, as we say and is not something that is mandatory and cannot be proposed an alternative to. So definitely no worries about the prescriptiveness of the guidance. It's something we will manage very well. Yet we have objectives which we can see industries bringing and saying, I don't know how to meet this objective on generalization guarantees quantifiable, for instance. That's one of the biggest fear we get from the floor and from industry, from applicants. So definitely that's the reason and the goal, I would say, with the MLIP to open this box, get to practicable, scalable, feasible, and implementable means. And then, of course, the choice will be on the side of industry, which ones should be used, not necessarily formal methods imposed for everyone. If it's the only one we know, then of course that will be the one we probably foster. But there will be surely different means available and proportionality depending on, for sure, the criticality of the application, as in the past, but also the level of AI, because the nature of operation is very different if you think level 1, level 2, and the mitigations involved are different. So that's what I would say overall for everything that is done in MLIP.
Thank you, Guillaume. So I guess the following one goes more for the data scientists. So did you consider formal methods D333?
So I'm guessing we're talking about the DO 333.
Yeah.
Yeah. So right now the standards that are considered are from the ISO and SANELEC regarding the implementation of the AI Act. So it's mainly horizontal standards. So the DO 333 is mainly a vertical standard. It's specific to T-avionic. And so the bridge between the horizontal approach of standards that is being currently developed, it's not yet finished, and the vertical ones, this bridge has not been done yet. So what we've done is mainly try to first do the bridge between the ISO documents and the SANELEC documents within the view of the concept paper from the EASA, first version 1 and then version 2. So the articulation between the DO 333 and the rest of the horizontal standards, that's still an open question. It's currently being debated in the SANELEC how we're going to articulate vertical versus horizontal, and we don't have yet an answer on that. So the short answer is right now no. These standards is not currently being studied during the MLIP project.
Thank you. So another interesting question. Are you planning to have a peer review process for the research topics?
Yeah, that's a good question. In EASA, we are not at the time, for the time being, having this kind of peer review process. What we are doing for MLIP is that we are opening the document to review and comments. At the end of the report, you will find an email address that some have already used to comment the report, and we will welcome any additional remark that you may have while reading the report.
Thank you, Xavier. So the following question comes from machine learning in maintenance. So in my experience, it's a quick sense environment. You have to consume a great amount of hours in trials, training, and calibrate models to obtain a bit of a result. I understand it's evaluated in the project to be selected and all stakeholders are consulted. Do we do this?
I think to have all the required answers to this question, because there is not only one answer to cover all the subject. So you need to be here for the next part of the presentation, where we will detail more the work done on the different tasks and mainly for the evaluation parts. So you have to be here.
So more to come. Stay tuned.
Yes.
Very well. So the following question it says, do you foresee any change in the objectives of means of compliance in EASA concept paper? In such a case, which ones exactly? Xavier?
I will start. That's a tough question. Of course, the intent is to identify some concrete means of compliance. So in 1 year from now, we really hope that thanks to this project, we will be able to develop further the means of compliance for the issue 3 of the concept paper. With regard to what exactly, which exact proposed means of compliance will be updated, maybe it's a bit too soon to say, but for sure we have in the safety assessment area some anticipated means of compliance that are dealing with generalization guarantee, where we expect to have some update thanks to MLIP. It's the same when it comes to learning management. We have learning management 02 and 13, if I remember well, that are dealing with the completeness and representativeness of the data. And likewise, for robustness, we already have identified some possible anticipated means of compliance that could be updated, and I believe LM13 is also one we have on our list. It will all depend on the outcome of the project, and I guess the final answer will be visible in the final report in 1 year from now.
Okay, thank you. So the following question has to do with the use cases. So the use cases identified are interesting, but perhaps not very challenging from a machine learning assurance perspective. Do you plan to issue more ambitious challenges for the community to interact with you and identify other very performing solutions in a broader community?
So concerning the different use cases, it depends on the point of view. So how you judge, in fact, the aspect of challenging more the machine learning community. So here we are dealing with real use cases. So we are working with internal Airbus projects, and also we are collecting and selecting more relevant open source data sets and models to make more public results. Concerning the use of other use cases, so why not? But the selection process has been focused on the EASA's interest concerning the use cases to be addressed on this project. So we have worked together on the first phase in order to select the use cases. We had a set of criteria to choose the different use cases. The first is the difference on the dimensionality of the data and also the complexity of the task. So this criteria has been filled, and also the ability to find open source data sets to make more public results. And considering the assurance and also the criticity of the aspect, I think it is very important today to have a good understanding of speech-to-text applications on the air traffic control. So some people here know more the impact of this kind of applications on the air traffic control and the safety aspect. And concerning the damages detection also, one of the main objectives of the Airbus internal project is to to accelerate, in fact, the process of maintenance and also establishing the planned and the unplanned or unscheduled tasks for maintenance operations. Today, there is, in fact, a challenging duration to address this kind of tasks, and the objective of this project is to accelerate this process, so to avoid more delays on the different schedules of the airports.
Okay. I think we have a compliment here. Yes.
Yeah, just a small compliment. The point of the use cases is not to develop new application of AI system. The point is to have use cases that are available first, representative, and on which we can try the different methodology, the different tools that are there in order to illustrate whether or not it's easy, it's feasible to apply the guidance from the concept paper and from the literature. So obviously the use cases are, this is not a project to build new use cases.
So Guillaume?
Yeah, no compliment, but just to foster interaction in the room, I saw the comment is from you, Alessio. I don't know if you have a specific use case in mind that you would suggest as being like the more challenging or more testing the tools and the methods?
So, I mean, I know that people use, I wasn't talking about...
Maybe
sorry,
you can use your mic,
here,
please.
because else the people on the WebEx will not hear. Yeah, thank you. Sorry.
Can you hear me now?
Yes.
Great. Thank you so much. I wasn't thinking about ML applications as such. I was thinking about methods in assurance for ML. And I think that nowadays, there's other challenges that ML methods, assurance methods for ML that can tackle. I'm thinking about runway detection, object detection, and so on, that perhaps are more challenging. And I was wondering, I agree entirely that the use cases identified are very interesting and relevant to the industry. I was also wondering whether, given that this is a kind of project that lasts a number of months and years, whether you could also issue some challenges to the community so they can interact with you and show capabilities that are more broadly available in the European community. That was the point of the question. And it's not really to develop new capabilities in ML, but really an opportunity for the broader community to perhaps showcase the capabilities in machine learning assurance, which is being developed perhaps outside the project. That was the point of the question.
Do you want to compliment? Okay. You can also have a chat on the coffee break later on, two of you. All right, so the following question has to do with generalization. So to what extent are the findings in the report derived from use cases, and to what extent from other methodologies, for example, common steps? If they are derived from use cases, to what extent do they generalize to all data-driven machine learning, and how to ensure such generalization?
It is a good point. I see that people are very curious about our work. So for a second time, I will not answer this question right now, because we have prepared a more detailed results to show, in fact, concerning the generalization evaluation, and also how we have addressed the different points that could harm the model's performance in order to ensure the model's generalization after training. So see you later.
So again, stay tuned. All right, so next question goes a bit like this. Are you planning to share results with the WG, which I assume it's a working group, 114/G34, a mapping of the EASA concept paper, and the ARP 6983 will be useful?
I believe we've shared with the Working Group 114 chairs the report, and end of last week. We will have some interaction with Working Group 114, maybe more toward the end of the project. We are defining these days the next communication events, and it's one possibility that we will consider for sure. I know that in the past for IPC, EASA IPC, we've done some WebExes to present results, so it could be a possibility we look at with Mathieu in the coming weeks and days. When it comes to mapping of the air with the concept paper, I will let you.
Yes, just to have an idea, we can discuss about it. We have tech talks within the working group. We will use one tech talk in probably early June for showing together with the Collins Aerospace team the result from the Formula IPC that we talked about. That could be another idea to do a tech talk dedicated to MLIP. Why not? Just a thinking. Huh? After a mapping, we are striving to get a mapping from the MLIP to the W-shape process in the EASA concept paper. Could see an outline of it in one of the slides. I think the mapping to the standard should be pretty straightforward in the sense that the mapping directly with the concept paper, from the concept paper to the standard is quite established already. So I think it's quite an easy thing to do. Now the important thing being how much the current MLIP results can promote or influence the pushing the guidance into the standard. That's maybe a discussion we could have in a tech talk. Why not? Yeah, let's see. Thank you.
Thank you, Guillaume. So the following question has to do with the tools. So tools are important aspects of this research. Which is a strategy to promote the development of the tool? One suggestion we are promoting is to provide the tool competition, benchmark, use cases in our interest. Is this making sense?
Yes, of course, it is making sense, in fact. And one of the objectives of the MLIP project is to come with a more generic development pipeline to promote the ability of the model to generalize and also to have more robustness and stability of the results. So we have reworked the point of view and the way we develop a machine learning pipeline, focusing more on the elements that can promote or harm its performance. So I gave a small answer now, and again we will have more details because the pipeline cannot be explained in a slot of 2 minutes to answer this question. Yeah.
So big expectations for the next presentations, I would say. Very well. So another question. In the area of data representativeness, do you plan to follow the idea established by Enable S3 Pegasus projects, where the validation of the data are achieved leveraging on the operational data? In other words, are you planning to work on dataset validation and not only on the verification? Yes?
Okay, then may have some things to add, but we work on analyzing the data itself. We are not trying to find if it's contradictory or things like that. That's not on the topics we're handling. So we consider the data valid and we just see if it's appropriate to create a machine learning system when it comes to repentitiveness, equilibrium, and these kind of questions, if there are corner cases and things like that. But the validation itself, it's not currently in the topics we are looking at.
Yeah, I agree with Olivier. Our idea is to provide tools so that applicants can analyze their data and work on their data prior to other analysis. So we are not into the validation process, I would say.
All right. So let's go for another one. So in terms of proportionality to the type of certificate, sorry, I'm jumping here. So in terms of proportionality to the type of aircraft, is all of the work today more focused on CS25 and possibly also to CS Vault only?
in the use cases we have selected for MLIP, indeed, we are mainly dealing, we are dealing with some possible CS25 application for the speech-to-text, but the AK6U is more in the drone area, and the AVI maintenance use case has to do with maintenance domain in general. So we are looking beyond SCVTOL and CS25 in MLIP. Then for the AI roadmap, when it comes to the AI roadmap and the concept paper, I would say that proportionality is included in the guidance, and it has been also substantially reworked in the latest update. And it's not only for CS25. Maybe you want to?
Yes, I can say a word about that. So first, thanks, Rodrigo, for the question and for following us from Brazil. No, in terms of proportionality, as Xavier just explained, we have a lot already embedded in the concept paper in terms of proportionality to the level of AI, to the criticality of the application. We started anticipating it in the chapter D with a big table that doesn't have to be in the final regulations or AMCs, but at least that orients the understanding of where we see proportionality going. Now the question from Rodrigo raises probably a third layer of proportionality, which is compared to the size and nature of the product. It's too early to say what will be done. Now, what I can say is everything we are working for is in a generic manner to be used in any type of product, and wider. When we say product, we think aircraft, but it's also for ATM, it's also for maintenance. So after regulation by regulation and CS by CS, certification specification by certification specification, we will have to clarify how much of all of that applies to, I don't know, a VTOL of category enhanced versus a VTOL of category basic. So this is something that is for sure a third layer of proportionality that will be respected when we deploy the guidance in the different products range and the different domains at the same time. So yeah, very important question. Thank you.
Thank you, Guillaume. So we have another question related to another use case, and it has to do with speech recognition. So ATC speech samples using voice over IP real example or recorded Airbus data.
So when we said Airbus project, so it means that these projects are based on real data recorded. It's not, in fact, a simulation of air traffic control speech, but it is a real speech recorded.
Thank you. So the following one has to do with the MLIP duration of the project itself. It goes a bit like this. How do you plan to ensure that the tools produced by the MLIP project are available beyond the duration of the project? Xavier?
Through MLIP, we are mainly identifying tools and methods and testing them on use cases. We are not producing tools that will be made available to the community. We will highlight what kind of methods or particular tools have been used, but we are not going to develop tools per se. Then when it comes to the public data set that will be used for the evaluation of the models, we will in the report we have made clear links to or clear reference, but we are not going to host this data set on EASA website or host some models. We will rely on third parties that have shared their data or models to do so. And yeah, you want to?
There are some cases, in particular in data, where we just have to re-implement some of the methods, and I think we'll make that available for whoever wants to use them, probably in the data case on the LNO website. But the idea is to have enough information in the document or in the reference of the document so that anybody can implement their own tools and put them in their production pipeline in an appropriate way, because it's very hacky, the kind of tools you can find for academia. It's not designed to work in an industrial context usually, so I think the method is the important part.
Thank you.
Just
yes?
to complement, the point is to illustrate the potential of the methodologies, not really benchmark tools against tools and say this one's better than the other one. The point is to illustrate that you can use this type of methodology to verify this requirement, for example. In the future, obviously, there will be multiple tools available, and you will have your own choice to make, but they will rely on technologies and methodologies that would have been evaluated during the MLIP project.
Thanks. So, why do you believe you can provide a generalization warranty that is stable after deployment and over time, such as the design service goal of the host platform?
Okay, so the pipeline that is under development on the MLIP project takes into account a set of elements that can influence the model ability to generalize after training, but also after its implementation. So there will be a set of verifications, of course, to be implemented and to be done after the model being embedded and implemented before it goes into the release and the real-life use. So these elements that will be identified after the implementation that could cause, in fact, the drop in performance, they will be implemented in some of a formal or in kind of features or something like that could be taken into account during the model training to ensure that we will have less possible in drop in performance concerning the generalization of the model. And concerning maybe the other details after its development, there should be a verification as for every tool based on software engineering or machine learning. The same process of verification will be implemented.
Thank you. Xavier?
Maybe to complement on Thierry's remark or feedback, I would say that for initial certification, we have a safety objective that requires to account for generalization aspects. And then we have added or we have updated the concept paper so that we have developed the part related to continuous safety assessment. And that it's requiring to define metrics, and if these metrics that are related to the safety case are degraded over time, then we have a second safety net that will allow us to react and to update the model if it is necessary.
Thank you. Another hot potato here. So, shouldn't we make a clear distinction in different ways of using the term validation, distinguishing better between the validation of data, validity of the data, and the validation that the AI application, machine learning component, is conformant to the user needs with respect to the operational real data?
Yes, of course, there is a difference in the use of the term validation. So, yes, here, so answering the different questions, we meant the validation of the model performance after the implementation. This can be relied on the verification of the targeted performance if we've reached these performances. So this is a kind of expert-based validation of the performance. But also there is another aspect on machine learning. When we train a model, we use a subset called a test data in order to see if the model can provide as the same performance during the training. But also there is another paradigm that uses a third part of the data set called a validation data set that is used, of course, during the training and after the training to validate the model's results in the point of view of experiment.
Thank you. So we have another provocation here. It goes like this. AI, it's evolving very, very fast. So how high is the risk of the methodologies and tools identified by MLIP are obsolete by the time the project ends?
It's an interesting question. Maybe the counterpoint I can make is that AI might evolve rather quickly. However, industry doesn't move at such a pace, and so industry will always have some lag between the state of the art that is currently published by the literature, the scientific literature, and the real usage of AI techniques within the industry. And so there will be always some modification to the document that has been published. The concept paper is already at version 2. There will be a version 3, 4, and I hope a further one. So I think this is completely normal, and I think that we still have time to process all of this new stuff that will comes up from the scientific community in time and with the pace of the industry, especially the aeronautic one.
Yeah, thank you, Arnaud, for this great answer. Just to complement also from the concept paper perspective, we have set, as we could see yesterday also, a number of assumptions, limitations also in terms of online learning is not feasible. We want to freeze the model. We are going for supervised learning in the first step, but we will expand. Just all these parameters, let's say, are still setting, let's say, the possibility of using AI to a certain subset of what indeed technology offers and what indeed research is bringing forward. So if we go stepwise, it's always our approach, but if we go stepwise with the right assumptions, we can believe that the tools identified, the methods identified in MLIP will be at least good enough for a start, for the first certification approval of, let's say, level 1 solutions with this boundary of offline learning plus machine learning supervised for a start, let's say. So we will go stepwise, and MLIP will at least serve a purpose, and definitely we will have to move with the pace of technology that is integrated by companies and applicants in the aviation domain, and we will do so, and we will create MLIP 2 and 3 and maybe more, as you said, Arnaud, if we need to get there. Yeah, thank you.
All right. Maybe the camera to the panel, please. Thank you. So we have a question here that is linked to Gary's question, so previous question. So I understand that the AI applications envisaged by EASA for aviation applications are trained before entering into service, right? Otherwise, how do you ensure that the system's compliance with safety, performance, requirements are not degraded later during operations?
For the MLIP project, we are working in the same framework as for the EASA AI concept paper, and we are indeed not considering some models that are evolving in service. It's first we have to eat the elephant one bit at a time, and I would say if we can already certify some application that are embedding AI that is only trained offline, it will be already an achievement. When it comes to online training, I guess it's on the roadmap, but I don't know at which stage, if you want to complement.
Yeah, we enter the fuzzy part of the roadmap, which is the pushing barriers phase 3, so definitely we will tackle that at that time. Nothing prevents people and applicants to use online learning, continuous learning in non-safety related applications, but when it touches safety related and later safety critical, definitely we will keep this limitation for a long time, I believe, because it doesn't first help managing the application itself on the AI assurance side, but also it's incompatible, I would say, with the current regulations. If I think Part 21, you cannot certify something that will just evolve in the field. Of course, you can do it under same thing, very careful assumptions of modifications of certain parameters in a certain range, but we are here thinking of something completely different, which would mean, I don't know, updating a neural network in the field. That's totally incompatible with something we can safely release, I would say, and certify from an EASA perspective. So this is where I think this will stay for a long time in safety related, safety critical, but when it comes to non-safety critical, for sure, the possibilities are wider. And we were discussing, for instance, on the maintenance side with Ralph Schneider, who is also in the room, our maintenance expert in the AI program team. It could be very, very useful in maintenance for some non-safety related applications, yet providing assistance to maintenance activities to deploy, why not, online learning. And this is something we will definitely develop as the time where it's needed in terms of guidance. We will develop something about that. But for the current scope, it's a strong limitation to outscope. Yeah.
Okay, so the following question, and the last one from the Slido, because then I will pass the floor to Mathieu for the other questions that we have on the chat. This question has also to do with the certification. So, we are already developing several solutions for aviation clients that make use of pre-trained transformer-based solutions, for example, not trained by us. And these are close to deployment in some of our clients' organizations. How does EASA consider that this type of solution could be validated or certified?
Yes, I will take it if you want to complement. This is one of the aspects that is not developed in the current concept paper. It's something we anticipated as being, let's say, the parallel to the notion of reuse or previously developed items in current development assurance framework. This is a big point. We have, let's say, we were hesitant to release something top level in the current proposed issue 2, but it was a bit too preliminary what we had. So we want to work on it. So on reuse, previously developed models or previously trained models, why not calling it like that? As well as transfer learning is a big topic in the field. So this is something we definitely will tackle in a subsequent release, I hope, by the time we release issue 2 at the end of the year. So after, of course, next question would be, okay, but then it will not have been consulted. We take the freedom, let's say, if it can help to release a bit more in the next release. It will never be a completely new concept, but if we can fine-tune the guidance, that would be great. And then definitely the concept paper will be up-issued with all that same content and consulted again at issue 3. So you will have plenty of opportunities to speak up and say you've forgotten this or this is not feasible. So this is really the strategy for now on reuse, transfer learning aspects. And yes, if you want to complement on the MLIP team.
Just a small precision. In fact, we have mentioned the pre-trained transformer models. Yes, we are using these kind of models for the speech-to-text, for example, use case in order to make an evaluation. However, you will see in the first results that we are training those models. We use a pre-trained model, then perform what we call a fine-tuning, which is a second pass of training of an already trained model in different tasks. Then we perform another training pass in our proper data set in order to make it able to understand what we are trying to do. So we have a different language, a different context, a different task. So we cannot, from the machine learning point of view, take an already published model, a pre-trained model, and put it in a production system to use it and expect good results. Because this will be a kind of magical concept, but we are not doing magic here.
Another
just
comment?
A really small point. This is also kind of a contentious point in the horizontal standards. We have the same discussion right now with the Sensenelec and ISO, to which extent there is a transfer of responsibility when some provider gives you a pre-trained model and you use it. I'm not entirely sure the answer has been quite finished in this scope of the standardization work.
Thank you.
We have a question on the PDI.
Yeah, maybe
It's more feedback to Guillaume.
I can take it, yes.
Guillaume.
So from Florian Michel Adolphe, similar direction, how do you expect that PDI concept, so parameter data item concept, can be or will be exploited for certification aspects? I would say in a short answer, it can be surely wider than that. We had this discussion also in previous steps in the CODAN IPC, anticipating that parameter data items, which are in essence configuration files for software, this is a piece of the guidance in DO178C, ED12C. We have something there that still could, let's say, that from the start could still seem matching the need in terms of, for instance, having all the weights of a neural network managed as a PDI. But we, I think it's written somewhere in the CODAN report, we excluded it in the sense that PDI is not tailored to manage this dimension of parameter data items, but also the intent of it. The intent of a neural network set of weights, for instance, if I just take this type of architecture, is really to completely parameterize the function, the complete intended function of the neural network. The PDI is really tailored to help on modifying a parameter, for instance, for calibration in a pre-operational phase. This is really a totally different nature of tool. So it seems appealing, but we kind of pushed it aside, saying this is not a practical tool for dealing with the complexity, the nature of neural networks. So it's again, it's a short answer. We don't exclude anything, but this is the way we have taken it in the guidance so far.
Thank you, Guillaume. I will pass the floor now to Mathieu for the chat.
Thank you. So we have two interesting remarks. So one from the DSNA. So we'll really be interested in the outcome of the STT-LU SIU use case. Less sure about the VRP possible applications. And the last remark was so some speech-to-text are open pre-source trained models offer several accents, independently to the language. So one way to augment the data sets available would be to generate synthetic data from those TTS models, add background noise, distortion, then use this as the STT training data.
Okay, so thank you for the comments. Concerning the data augmentation, first, for the speech-to-text use case, we had not the problem of data dimensionality, unless on the task one we will identify further problems for concerning the required data for training, but it is not the case so far. And the use of automatic text translation into speech, what we call text-to-speech, in order to make a data augmentation for such a specific use case, it is not, in my point of view, a good idea. Why? Because we have, first, we have a large data set recorded from the real life for air traffic control, so it is more relevant to use real data than using simulated data. The second point is that concerning the use of open source data sets, there exists today a lot of published data sets concerning the air traffic control speech-to-text, and we have also found that there exist some data sets that make simulations of speaking air traffic control instructions. So these are recorded data sets in different situations. So these are not real life situations. And so far, our analysis mentioned that the use of the real situations used data is more relevant and more important than using the simulation based data sets. And so you can understand that the use of the automatically generated speech is not a good idea. We will also have a base concerning the results of the model that will be focused more on the the model that have generated this speech. So, provided all these points, we do not today project into using this kind of data augmentation for speech data, maybe later or for the other use cases if needed, but not so far.
Thank you. So we're going to do a small break now. I will invite the guests in Cologne for a coffee, and we will resume at 11:20 for all. Thank you for all of the questions that we got online. Thanks.
Okay, we are back. So we're going to continue with the presentation of the 3 tasks, and we will start with task number 1.
Okay, so hi again everyone. I'm Sven Ribeiro, I'm the Task 1 owner, so I'll have the pleasure to walk you through the progress of the MLIP Task 1. So this task focused on data, and more specifically on data completeness and representativeness. So we will start with the definitions of the central concepts here. So we consider that the dataset is complete if it sufficiently covers the entire space of the ODD. And we consider that the dataset is representative if the distribution of its key characteristics is similar to the actual input space of our intended application. So there are several objectives that has been completed in task 1 so far. The first one is to draw a state-of-the-art. This state-of-the-art discusses factors of influence for the assessment of completeness and representativeness, and also lists a number of methods, tools and approaches that allow such assessment. The second objective is a synthesis. So we presented a synthesis of all the methods that we discussed earlier in a tool called the selection grid. And finally, there was a testing phase where we started the manipulation of these methods with actual datasets. So the first round of implementation worked on generic machine learning cases and not specifically the MLIP use cases. So that's why I will be discussing a bunch of different datasets. So first, talking about the state of the art, so we identified a number of influence factors here that we structured around 3 axes. The first axis was called technical requirements. It's basically all the elements that will appear in the ODD and that can influence the completeness and representativeness of the data. So this encompasses things like intended behavior of the application, the model architecture that has been selected, the dimensionality of your data, and also your intended level of autonomy, performance, robustness, resilience, or stability. The second axis is the processes, so all of the processes during the development of the machine learning application that have an effect on completeness and representativeness. So this encompasses data management requirement, data quality improvement, such as data augmentation. We also included data synthesis as a separate process, and also data sampling, labeling, and any form of pre-processing that can be performed prior to training the system. And finally, the third axis is any other data quality requirement that can interact with completeness and representativeness. So this includes things like balance, relevance, diversity, or currentness. So the main takeaways of the state of the art is that first, the assessment of data quality in the field of AI generally lacks maturity. By that we mean that there is not a very structured approach that is structured around the identification and quantification of influence factors and their influence on the data and their interaction with each other. The other takeaway is that an exhaustive data quality, like enforcing data quality from all sides of data quality requirements might be hard to achieve because some data quality are mutually exclusive. If you consider, for example, that you want to enforce perfect balance in the classes of your data set, then you would completely giving up on representativeness. I would say secondary takeaways from our state of the art is that in literature there is still a culture of curating the data, and if they are not curated enough, it's okay because the model will sort it out, which is not always a good strategy. There is also no off-the-shelf magical method that will allow you to quantify any factor of influence and its influence on completeness and representativeness. And finally, high-dimensional data remain a challenge because there are some methods that can work on high-dimensional data, but some may require some adaptation to work on this kind of data. So it's always something to bear in mind. So moving on to the second objective, so building the selection grid. So we took the more than 60 methods that we analyzed in our state-of-the-art, and we boiled it down to 20 methods that made it to the selection grid. They were selected using basically two criteria. The first one was the maturity of the method. So the idea is, does an implementation exist for the method, or is the method implementable in a reasonable amount of time, considering the time frame of the MLIP project? And also the method had to be in line with the project objectives, so it had to allow, or at least we thought that it can allow the assessment of either completeness or representativeness. And you can see on the right side of the slide that some factors of influence have more associated method. That's because some factors are more straightforward to find a method to work on, and some are not. So moving on to the testing phase, so we worked on several methods. The first one was PCA. So PCA is a principal component analysis. It's a classical dimension reduction technique. We decided to test it on AK6U. This is the only method that we could test directly on a use case from the MLIP project, and that's because AK6U had the property of assumably being complete. So it was very interesting for us to use a dataset that we knew was complete, and see what PCA would highlight on it. So the results are extensively discussed in the document. Here you can see one of the graphs that we have on our analysis. PCA actually highlighted some particularities of the AK6U dataset. So we had to perform further investigation. All of this is detailed in the document. And we drew a number of conclusions, and it was quite an interesting analysis. I want to signal that we are aware that maybe AK6U is probably at the edge of relevance for this method. But again, I want to emphasize that the idea was to use AK6U to gather information on PCA and not the other way around. The second method that we tested was entropy, Shannon's entropy. For this method, we used images. So our target use case in the MLIP perspective will be AVI, but for our preliminary experiments, we worked on the CIFAR 100 dataset, which is a small image classification dataset that has the property of being perfectly balanced in terms of number of samples in each classes. And we also worked on the ROSE dataset, which is a dataset for image segmentation that we have at LNE and that we are particularly familiar with. So entropy is quite an interesting metric to use because it can be used at different levels. You can compute entropy at the label level and also pixel-wise if you consider images. So you can get a lot of information out of it, but it's always coarse-grained information. So we would advise to combine entropy with other metrics, and of course the perfect combination of metrics is not yet determined. Here you can see a result of the pixel-wise entropy on the CIFAR 100 dataset. Just to give you the broad ideas, we can see that
all the boxes are quite homogeneous, and we also see a lot of outliers in the form of the little dots, and that shows that okay, our data set is homogeneous as expected, but there are a lot of outliers. So maybe we could investigate deeper into what are these outliers, maybe identify outliers in the sense of the EASA, so like corner cases and things like that. So these graphs I will not comment because I won't have time to do. So third method was the graph analysis method. More precisely, we worked on the graph analysis of the feature combination of a dataset. So our target dataset would be AK6U here, but we worked on a much smaller dataset that's called the Titanic dataset. So here you can see an example of the feature combination graph that you can obtain on three binary features. So the idea is to assess visually the completeness of your dataset by identifying feature combinations that have less than a certain number of samples associated. So it's a really easy tool to use. It's very visual, which makes it a good complement to PCA, because PCA is well suited for high dimensional data, for the visualization of high dimensional data, while this method would be more suited for the visualization of low dimensional data. Nonetheless, our implementation for the moment needs to be scaled a little to be perfectly operational, but we still have some results that are discussed in the paper. And the final method that we tested was sample similarity analysis. For this method, we tried a metric that is called the degree of correspondence, more specifically. And in order to cover all the type of tasks that are discussed in the MLIP project, we worked on speech recognition data. So our target use case will be the ATC STT dataset, but our experiments were done on the fluent speech comments dataset, which is again much smaller and easier to manage. And what we found is that specifically degree of correspondence happened to be quite inconsistent and intractable on the speech embeddings that we used to compute our similarity. So this specific method will be put aside, but nonetheless, similarity-based analysis remains very interesting in our opinion. So we will continue to develop this approach to provide further results in the later iterations of the project. So the takeaways of our testing phase is that no method is self-sufficient. You will always need to combine methods, tools, and metrics to provide a maximum insight on the data. No method is universal. The method or combination of method that you use will always have to be tailored to your task or even your dataset. Also, completeness and representativeness can only be estimated with respect to the ODD. So you won't have a method that allows you to say, okay, my data is complete with respect to the entire universe of possibility in the real world. And finally, there is a trade-off between completeness and representativeness. If you consider corner cases are usually rare in terms of statistical occurrences, but their impact can be very serious. So you want to ensure a decent level of performance on these cases. To do that, you would have to put more sample in your data set of these corner cases. And if you want to be perfectly representative, that means you have to scale all the other cases, which is not either possible or even desirable. So in this case, you would put more corner cases and trade a little of representativeness for more completeness. And the next step for task one will be to adapt the method that I just told to you about to higher scale dataset. And we will also, of course, continue to test the other method of the selection grid. So thank you, everyone, and let's start the questions.
Thank you. So let's take a few questions. So we actually have one for now. So ODD is nominal design operational envelope only, or you also expand in your use case to abnormal condition that reduce or expand the ODD?
depend on the definition of abnormal conditions, I would say. In our case, it's well, the ODD includes specifications for normal operating conditions, degraded conditions that would include robustness constraints, and also integrity, even further degraded conditions that would include loss of integrity of the system or the component in which the system is integrated, which would correspond to resilience. So that's what is discussed in the paper.
Thank you. So a remark from for the previous break for Thierry. So real data will always be better than synthetic data, of course, but if you don't really use what if you don't have real data? There are cases where implementing synthetic generation requires way less time and effort than first getting real annotated data, then annotating it while providing a representativeness that is good enough to significantly improve the model result. As an example, in our case, French spoken ATS messages.
Yes, of course. When we do not have real cases, the data sets, we need to use simulated data and simulated situations to produce the needed data to train any kind of machine learning application. In case of the automatic speech recognition for air traffic control, so, as we said, in our case, we have these real situations data sets provided by Airbus projects, but there is also open source data sets that are based on real life situations, recorded data sets such as the ATICO data set, which is an open source real life data set for ATC. And using the generated data sets, one of the major problems when we do not have real life data sets, we go to the option of generating automatically a data set, but after this we need to validate what we have generated. In case of the data set is perfect, so we used a perfect model that generated the data set and utterances that are closer as possible to a human being speaking. This is perfect. But if this is not the case, we need to verify all the spoken instructions, and this will be such a time-consuming step, and also the cost will be huge. So this is an option to adopt, but why not?
Thank you, Thierry. Okay, another question. So how do you define ODD for your cases, for your use cases? Are you going to provide this definition? This is a big challenge.
The definition of the ODD is not in the document. I think we define it, and we use the EASA definition in any case. Yeah. So that's the answer.
Okay, so everything is in the document. Okay, so another question. So, sorry. There are many commercial tools available for preparing, clearing, balancing, analyzing data sets. Did you also evaluate a commercial tool against aviation needs, or was it just methods?
It's method tools, even approaches like a little more theoretical, so to speak. We are planning on testing two commercially available tools, but it's not it's not a benchmark, and it's not really about the raw result that you can obtain on aeronautics use cases. It's more about the general information that you can get, and providing as much information for applicants and future work on these questions. And it's not really a prescriptive or benchmarky approach for us.
Thank you. Okay, another question. So for pre-trained models, how can you verify the data? The data quality attributes, completeness, representativeness?
That's a good question. I think we could consider tools for retro engineering data. That's possible, but that's not in the scope of MLIP. And other consideration that we might express would not fall into the objectives of the MLIP project. My take would be, as the user of a pre-trained model, you should ensure from the company that provides the pre-trained model, you should ensure what has been done to clean the data. But that's a prescription, and it's not the objective of the project. So.
Yes, and also for some cases when we take a pre-trained model, that it means that this model is open source, and in general it comes with the data used to train it. So from the point of view of perspective, we can make the same analysis that we are adopting for our data sets to this open source data set. So the tools that will not change. So we will make a verification on the completeness, the representativeness, etc. But also we need to compare what the model have learned. So when the data is available, I think this will not be an issue.
Thank you, Thierry. Okay, so last question. For certification, verification, and validation of data representativeness and completeness is a key challenge since any applicant can make claim to reach these properties. Why data verification, validation is not the scope of MLIP?
I would say because MLIP is a research project. So we don't go as far as verification and validation. We don't pretend that the result that we give will be solid enough to be used as is. I think it's absolutely not the claim of the MLIP project. We are really here to help. How would I say? Shed light and encourage future applicants to put a nice methodology in place that will allow them to provide the best effort.
Yeah, it was a very good answer from Sven. We are not doing a certification project per se here, so we don't expect from the research consortium to produce means of compliance with the level of details and thoroughness we would expect for a certification project. It's really more about identifying methods and tools and testing them on real use cases to see how they can serve the compliance demonstration.
One more question. What is the benefit of generating data synthetically for training purpose instead of using the logic used to generate the data in the trained model itself?
I'm not sure I understand the second part of the question. No, but it's like I can't process it in my brain.
Yeah. So basically, if you want more data for your training purposes,
yeah,
you can synthetically create that data.
Oui.
But in the process of synthetically creating that data, you are creating a logic based on which that data is generated.
Yes, but collecting groundwork data is first, it's expensive, and second, you cannot entirely you can't create a perfect simulator. If we assume that you can create a perfect simulator, yeah, it's a bit it might be a bit odd to generate synthetic data. But the idea of synthetic data is that it's cheaper and it allows you to play on volume rather than quality. In this regard, there is always always a trade-off. You can't generate a heap of junk and just expect it to work better than real data. But in general, the motivation of generating synthetic data is that it's cheaper and you can get a lot more.
So before you actually consume it in your training purpose, you would want to do some kind of validation.
Yes, of course.
Okay, thank you. So thank you for all the questions. Thank you, Sven. We'll continue with the presentation of the task 2.
Yeah, so the task 2, which is dedicated to generalization properties. Based on the state of the art, we have analyzed available methods and tools to evaluate the generalization guarantees, the barriers in generalization guarantees, and the limitation of available methods and common practices. Thanks to this analysis, we have identified and selected methods and projected them into the W-shape approach. The next part of the project is dedicated to experimentation and evaluation, and we'll show at the end of the presentation the first result we obtained. I want to start this presentation with a quick reminder of what is supervised machine learning algorithm. So the problem is the following: we have data, and we ask questions about those data, and we want the answer. So, for example, what is the animal on this picture? The answer is a cat. To find the right answer, we are using parameterized algorithms, and we'll use some examples. So, for example, picture, where we will tell this is a dog, this is a cat, and we'll configure the algorithm thanks to an optimization during the training phase to optimize the parameter to have the minimum error on the examples. And what we want at the end is that the algorithm is capable to provide good answer on unseen data. The idea behind this statement is simple. It exists regularities in the data which are discovered during the training phase. In other words, training data are somehow representative of the unknown phenomena underlying the data. And here we are clearly making the link with the representativeness and the completeness that Sven just presented before. Coming back to generalization properties, the generalizability of models, it is its ability to generalize the learned knowledge to new contexts and environments. And what we want is to provide guarantee on the performance of the trained algorithms on the full domain, on unknown data, I would say. For that, we can use statistical tools such as the generalization bounds. I will not develop here the generalization bounds as it is the focus on the next slide. But what I want to highlight is that those generalization guarantee can be grouped in different aspects depending of their dependency to the data or to the algorithms. For example, the Pack-Bayesian bounds are data dependent and algorithm dependent. In the opposite, we have the VC dimension bounds, which are not dependent neither from the algorithm, neither from the data. On top of this success estimator, we can use also the necessary condition but not sufficient to have a good generalization, which we call here the success indicator. So, for example, we can compare the performance of the trained algorithms on different data sets. The one we use to train the model, and a test data set containing the data never seen by the algorithms. Then we can compare, and it is a way to identify some potential issues such as the underfitting or the overfitting that can occur during the training phase. I want to mention here also that there is testing-based approach where we check the correctness of the result during adversarial attack, and this part will be further developed during the speech of Arnaud concerning the task 3. The generalization bound, it is one way to guarantee, let's say, a minimum level of performance of the algorithms on the full domain based on what we know, which is the empirical risk that we have measured. So a general formulation of the generalization bound says that with a high probability, greater than 1 minus delta, we have the gap between the generalization performance and the empirical measurement we have done, which is lower than an epsilon. And this echelon is the generalization bounds, which can depend on the hypothesis class we have selected, the number of data, the delta, which is the probability of the bounds to fail, the distributions, the algorithms, or the parameter of the trained model. In the literature, there is several bounds which are defined, and depending of the different theoretical frameworks. So, for example, we have the uniform convergence base, where we have an example of the VC dimension bounds on the bottom. We have uniform stability base one, where we use the property of an algorithm to be stable with regards to different trained data sets. We have the algorithm robustness base, where here the property we are using is that the algorithm is maintaining a good performance in different contexts, and here also we are making the link with the activity of in the task tree. And the two other frameworks that I want to mention is multi-alley information and measurement related to optimization procedure. Based on this literature review, we have selected 17 bounds, which are, and the selection has been based on the use case applicability, and also the analysis on the hypothesis, and we select the one with the minimum restriction implied by the assumptions. I will let the floor to Tiziri, who will continue the presentation.
So far, we have analyzed different parts of the state-of-the-art concerning the data analysis and also the development analysis of machine learning applications. Now, from the industrial point of view, when we aim to put ahead a machine learning application, we start from a task and data analysis, the identification of KPIs, so the key performance indicators, and we target a good model. But how we can view these criteria of such a good model? We go through different steps from modeling, the training, the evaluation, testing, adjusting, etc. All these well-known data science steps in order to provide this good model. However, today there exists a set of AI issues that harm our machine learning models and prevents them from being released into the target system. We have identified 4 main classes, but these cannot be as exhaustive as possible and cannot be only these kind of mistakes. The first one, we call it the misunderstanding of the generalization bounds. So we try from the first step to estimate the ability of the model to generalize, and we try to use a set of bounds in order to estimate this ability. However, some bounds cannot be applied for all types of data and all types of tasks. So as Jean-Baptiste explained, there is a set of different methods. We need to be careful while choosing this kind of methods. The second one deals with several mistakes that we can put all together. It's called the pitfalls in practice. So we have a set of data analysis and preparation and the construction of the representations that we all need to implement, but sometimes these representations, the choice of the data quality, the data volume, etc., is not appropriate for our targeted performance. Here we are focusing on the targeted performances. It's not only the experimental point of view. The third one is the gap between these two paradigms, the experimentation, evaluation, and also the real-life application and what is the real performance that we are targeting. Sometimes we see some applications where one first targeted performance is 95% or 85% of the measure X, the accuracy, the relevance, etc. But how we can interpret, in fact, these measurements viewed from the industrial point of view in our experimental process. And also, so this good model, how good enough it is, in fact. in order to answer this question, we need to select appropriate performance indicators, how to translate these industrial KPIs into a good measurements, into a good training objective, etc. And finally, we need to handle a set of machine learning and deep learning testing limitations, because today there is a lot of industrial applications that are based on what is known as massive testing, but it cannot cover all the evaluation points that can be covered by the experimentation pipeline, by an approach based on the experimentations, the evaluation, etc. So we need to put both the paradigms of the evaluation and the validation together in order to have as exhaustive as possible and covering evaluation pipeline. So in order to answer all these different objectives, this one. Okay, sorry. In order to answer all these different questions, so we set 4 main objectives for this part of the project. The first one is to deal with the models overfitting and underfitting, since this is in fact the first problem that prevents model from being released. We train our model from the experimental point of view. It is good enough because it has 90% of accuracy, but is this model really generalizable to other kind of data on the industrial context? The second one is to bridge the gap between the experimentation and industrial expectation. But what is this gap between both the points of view? We have a set of metrics to be adopted to the identification of the KPIs. We have a set of machine learning testing and evaluation properties that can be combined together, and there is a lot of elements that can be put together in order to fill the gap between both the evaluation procedures. The third one is the handling of the out-of-distribution samples, because as it has been discussed yesterday, there is in the real life situations that we cannot anticipate. So while developing our model, we know that on the real life we will be some days faced by these exceptional situations. So we will try to represent them during the development of the machine learning model and during its training in order to give the model the ability to anticipate better. And finally, we will present the generic or the use case independent pipeline for machine learning and deep learning applications development, which is focused on reducing the impact of all these different pitfalls and promote its performance after being released. So we start by defining the target application from the industrial point of view. How we can view this target application, putting together the task, the data, and the KPIs. So we have both the input and the output spaces. We have our mapping function that corresponds to the model that will be selected at the end of the training. However, we have also a set of metrics and benchmark. These metrics and benchmarks corresponds to the evaluation measures and also the acceptance and the validity indicators. When I say as a data scientist to my project manager, I have this X% of accuracy, he will ask, what is it? For example, I need to translate correctly the ability of the model to perform correctly this task into a good evaluation pipeline based on those metrics and a benchmarking framework in order to check its validity. And finally, as we said, there exist some special situations that our model can be faced after. At the final equation, we need in fact, to represent these elements, these input elements or conditions that can directly impact the ability of the model to generalize and that will harm its performance after the implementation. So, after this analysis, we have developed this pipeline based on 4 main loops. It is still under development, so this will be updated for sure further on by the end of the project. So the first step will be focused on the data qualification and quality verification, including all the criteria of the data representativeness, check the volume needed for the training. Do I have these sufficient data? Do I have these real-life data? Do I need to generate data, etc.? All these steps will be evaluated on this first loop on the a priori evaluation. This a priori evaluation takes into account also the set of generalization bounds and the set of metrics and standards, how I will accept or reject the model's performance. So here is the second loop where we focus on the development and the adaptation of the machine learning model itself. Here we define its architecture depending on all the different elements from the priori evaluation, these generalization bounds, the task criteria, the metrics, etc. We develop this model and then we go into the training. Going into the training, we will check the ability of the model to generalize using this part of data called the data test. If my model is able to produce some performance that I targeted from the beginning, so my model can go into the implementation. Otherwise, taking into account the influencing elements that we have anticipated for the target application, and also the set of KPI, the measures, the benchmarking of the acceptance and the tolerance, etc., I could loop again into the training of the model, perform a posteriori evaluation, etc., until the model be accepted based on the benchmark that I have identified for the target application, and then go into the implementation and the embedding of the system. But it's not finished. This model, after its implementation, will be also evaluated, and we need to verify its ability to keep the same performances or to stay into the area of acceptance from the point of view of industry. Here we have a set of inference environment elements. So this is the best word that I found, but this can be a discussion about how we can call all these elements that come from the implementation environment. Here we call it the inference environment elements. This can include the data acquisition and also the difference between the implementation environment, the used materials, etc. All these elements put into the part of the representation of these elements in my task, so I will be able to anticipate as more as possible. And then here, this will be a step of evaluation also between 3 and 4 in interaction with the generalization evaluation, but also the robustness and the performance stability of the model. Concerning the evaluation part, so for the task 2, so note that the result that I'll be showing do not appear in the on the paper, so on the public deliverable yet, because we continued working on this evaluation part until the publication of the report, but they will be part of the next version of the document. The objectives for this evaluation part is first, analyze the existing pipelines. As we said, we are provided with data and models, existing models from the Airbus project and also the open source materials. Now, as a first step is to analyze how these models have been developed and trained. Do their metrics and evaluation criteria meet really the objectives from the point of view of industry? And then finally, compare the estimated generalization for these models before training to the real generalization and performance of the model after its training. And then finally, identifying all these limitations will lead us to make suggestions on how we can make better these models. So the experimentation, so for more details on this part, I think I will go a little bit faster. So you can feel free to ask more questions about these details. Concerning the first results, so we started from comparing the Airbus internal models to the fine-tuned models. Fine-tuned as the retrained models on the Airbus datasets. All what is mentioned on red, it means that the model is not good because we are, on this experiment we are based on the word error rate, which means that we check how many times the model can make an error translating correctly a spoken word into a text. So as a first analysis of these results, the trained models on the Airbus dataset, so the models that we have got from those projects, provide so far the best results because they have been trained on the datasets coming from French airports. So we use the same materials, the same equipments to get these data, but also when evaluating these models on the test part that has been constructed using the same equipment and the same conditions. So there is a base into it. That's why we have used the open source data in order to evaluate that same models. And here we noticed that the results are unfortunately bad. And compared to the open source data that are averaged on the Airbus dataset, but still perform better before and after fine-tuning on the input datasets. And finally, we analyzed the learning process of the fine-tuned models using the Airbus dataset of more than 6,000 utterances, and also evaluated and trained using different numbers of steps. So the models are not overfitting, and the results showed that these models perform better, and the evaluation process is still ongoing, so the better results are coming soon. Yeah, I think it's okay. So to conclude, sorry, I have not finished yet. So to conclude, concerning the task 2, we have just started the evaluation the evaluation process of the methods, and as a next steps, the general framework that we presented will be also developed and put into test in order to verify the different selected methods for the generalization, but also for all the different other tasks. Thank you.
Thank you. So I think we're running a little bit out of time, but so we'll take just 2 questions, so the most popular questions. Okay, so why use the word guarantee for generalization instead of confidence level assigned to the deployed model in consideration of all rigor applied, such as formal methods? Guarantee is questionable as there is no guarantee on a black box.
As a first step, so we focus on the generalization guarantee as one of the objectives of the MLIP project, but using other criteria to evaluate the same performance, why not? This is an evaluation process that is still ongoing and under development, and all the feedbacks on this process are welcome.
maybe let me add on the choice of the verbiage. Generalization guarantee is a term that we've used in the EASA AI concept paper. It's also a term that we use in the regulation, in the CS25 or in the associated guidance material in the IMC. It's a term that we use, that is used in scientific publication. We can assess if there are better terms, but at the end of the day, we have this particular challenge that needs to be tackled by the applicant. That is, we want to make sure that the performance on unseen data is acceptable. And how we call this concept can certainly be improved, or we can refine definition, but what we want to make sure is that for safety critical application, we won't have unexpected behavior once the system is exposed to unseen data. It needs to be, it cannot be for sure be an absolute guarantee, but still we should have, let's say, some sufficient certainty that with that the risk is extremely remote or extremely improbable, depending on the criticality of the failure condition, to speak in airworthiness term.
Thank you, Xavier. So, okay, so last one question. So, for
maybe Gary is in the room, so maybe he wants to add on it.
No, that was a good answer, Xavier. It's just the end of the day, you said the word absolute, and guarantee implies that it's an absolute. And unless you change that black box into a white box by a finite ODD, you can never, for me, say there's a guarantee. You will have a DDP, and that will express what has been achieved and what are the limitations and the envelope. But I just say that I would advise that you avoid the word guarantee because it's sensitive. Thank you.
Thank you. Okay, so we're done with the questions. Let's continue with the presentation of the task 3, and we'll take all the questions for after the conference for the lunch. Thank you.
Right. Is it working? Yeah. All right. We skipped that. All right. So task 3 is the last obstacle before lunch. So I'll try to be on time. Don't worry. So task 3 is about robustness, so algorithmic and model robustness. It has several objectives. So far we have mainly focused on the first two, which are the review of the methods and tools available to assess robustness, and also to consider the specific case of corner cases or edge cases that the ML system might be subjected to. In the future, in the next phase, we'll also work on the identification of source of instability during design and during operation. And finally, we will work a lot on the implementation on the use cases, which I'll taking a little later. So, oh no, it's okay. All right, so but why talk about robustness? So far, robustness has been identified as one of the key requirements from the high-level expert group from the European Commission, along with the others. Obviously, it's not the only one, but at least this one has been mentioned. And since the high-level expert group has driven the reflection for the European Commission, it has been also translated into the AI Act with some requirements specifically mentioning that high-risk system has to be robust. However, none of them has defined exactly what they meant by that, and they didn't also give the recipe on how to measure that. And so everyone agree, I think, on this room that AI system has to be robust, that there can be some issue regarding robustness, because there has been several examples of system that fails once in production or even during testing. And so we all know that this challenge needs to be addressed, but the question is how? So why talking about robustness? So at the bottom from the concept paper which we used as our main guideline for the work. We know that it's tightly linked with the definition of the domain of use, of the operational domain of use that your system is going to be used on. Obviously, open world constitutes a high challenge in terms of what is the ODD corresponding, because it's unbounded, just as previous speaker just said. But we want to still have some definition of the ODD with parameters that can be bounded in terms of numerical, that can have some notion of the distribution of these parameters. And so we have to consider the broad range of cases that can occur. So obviously you can have nominal cases where nothing weird is going on. You can have variation of the nominal cases where maybe the plane can be a change of color, or the sky can be a different color at this time, but maybe not every color. You can have the adversarial cases where someone is trying to fool the system. So here you started to think that, well, that's not really safety concern, that's more cybersecurity concern, right? And so you're kind of a discussion there that, is this really something that should be considered within the ODD in terms of robustness? And finally, you have obviously the non-existent cases, which this one I've generated using some generative AI feeding with the previous images and telling me that give me 8 wings planes and give me that. And so obviously these cannot occur. Well, I don't think so, I hope. I'm not sure that you would certify that this kind of plane, but these can be inputs that can be considered even if they're not existent. So you have to find boundaries there, a frontier, or where you want to go in terms of testing. So the work that has been done in the DEAL project propose a nice theoretical framework to view the domain, the ODD, as first you have the nominal conditions where you're comfortable, where you probably have a lot of your training data. And then you have the more you go to the edges of these ODD, you have stuff that can occur rarely but have impact, and stuff that can definitely put your system down. And then there is the outside of the domain of use case data points. And to address all of these spectrum of the domain, the literature says that you have several techniques available, several approaches they can use. That you can use statistics, you can use formal methods, you can use empirical methods. And so what we try to do is try to think about how we can use these techniques, which advantage, which kind of drawbacks they have, in order to cover as much as possible in a meaningful way this domain. So to do that, we looked at several sources of literature, and so we looked at the EASA, we looked at obviously at the concept papers, and also some stuff that come from the UK. And what the first work we've done was trying to align all of these definitions and concepts, because each one is using the terms with a different exception. So for example, robustness is not the same in the ISO and in concept paper. Stability is not present really in the ISO, but is present in concept paper. Same for the corner cases. And so each one is using these terms with different meaning. And we will try to see where are the equivalences and where are the stuff that someone covers and the other does not cover. Also, the literature is proposing different kind of requirements, some of them on the whole life cycle, some of them part of the life cycle, and so we're trying also to align all of that in order to have something consistent at the end. And we consider obviously the 3 types of approach, so statistical, formal, and empirical, in order to cover as much ground as possible. Once we've done that, we try to assess the maturity of each approaches, giving the state-of-the-art in terms of scientific literature, but also in terms of available tools, which are maybe academic or not, in order to see whether we can use them in order to apply them on the use cases. So once we finished that, we identified several requirements that can be expressed and that has meaningful meaning across the literature, which are these. We have a lot of requirements that deals with stability notion, whether it be on the training algorithm or in the model itself, whether it be the model just trained or the model put into the hardware, the inference model. So we have also this kind of constraint to analyze. We identify that some of the literature also is kind of consistent in the terms of bias, in terms of variance. The literature also propose requirements on the relevance, which is kind of tied with the notion of explainability, which is not directly covered by MLIP, so you won't find a huge literature there, but this is quite a heavy topic to process. And you have also the requirements regarding, for example, reachability, which is exactly the point of the ACASC use case. You want to verify whether or not your system can reach some part of the space you don't want them to reach. So what we think is that, first of all, there is no one method fits everything. We need to combine methods. And the gut feeling here is that once you are on the nominal area of your data space, probably formal methods are quite good because you can explore widely within this space. You have a lot of data points. You know also the perturbation that your system can have, and so you can model them within this kind of safe space of the nominal approaches. But when you go to the outside of your ODD, the high dimensionality of your ODD, it's trying to, it hinders your efforts, because if you have an n-dimensional space, well, you have an exponential number of corners in your space. And so here, the more you go to the outside, the more you can maybe rely more on statistical approaches, which are more scalable in order to measure that. And at the very end, you might only need empirical methods that are able to simulate this kind of really extreme cases on which you want to test your system. So this is the kind of gut feeling we have regarding of the definition and the availability of the methods and tools out there. So each method have obviously advantages and drawbacks. So statistical methods, you need to have some form of some knowledge of the distribution of the parameter you want to sampling in it. And so this is aligned with the definition of the ODD proposed by the concept paper, which has as a requirement for the ODD itself to know the distribution. So you might be able to do some sampling within the input space, whereas in formal methods you can, at the current state of the art, locally assess some property. And the way you define this locally can be various. You can have different shape of the input space you want to consider before moving into specific formal methods to assess it. And using empirical methods, generally speaking, you will rely on some expertise or some subjective opinion on what you want to test and what kind of data points you want to experiment on. Because as an expert, and so it requires a human there, you want to verify something in particular. And by combining the three approaches, you might be able to cover as best as you can the input space and of the ODD. For the corner case exploration, so here we are really looking at the stuff that can break your system almost. Interestingly, the automotive sector again proposed some interesting approach by considering not only just data points within a space of the ODD, but trying to have also a semantic approach to that and say that your corner cases can be described either as a high-level corner cases, for example, a scenario that is not likely to occur very often, or you can grind down to maybe one object in my scenario is something unusual, or maybe the domain of my scenario here is a little bit different, or maybe there is an anomaly at the pixel level. And so here we see another way to view how the corner cases can be described as not just parameters that has very low probability on the ODD, but also at the semantic level. So finally, we considered all of that, all of these requirements, all of these work that the applicant might have to do at some point regarding the stability, the bias, the variance, the relevance, the reachability, the corner cases, and we try to verify whether or not each kind of methods can help achieve that. So obviously with the color code like that, it's rather simplistic, but the main work will be at the second phase of the MLIP project when we will try these methods on the use cases to have a better feeling of whether or not they're applicable. Going forward because, yeah. So in terms of next step, like I said, we kind of finished the theoretical works, all right. Now we need to move on to the more practical one. And so we're going to heavily rely on the 3 use cases that was presented before in order to see whether or not these methods can have applicability and mostly scalability, which is kind of one major component for the applicant, because a method has to be applied in a way that is possible. And I think I'm stopped there in order to save time.
Just we can take maybe one question. My proposal would be, we are running out of time. We need to close the conference officially. My proposal would be that we stay like 10-15 minutes more after we close completely the conference, just to take additional questions on task 2, task 3, because we have squeezed a bit the Q&A.
Okay, agreed. So as of right now, there is no question for task 3, so I think we can conclude.
All right. Thank you.
Sorry. Okay, so what's next for the future for MLEAP? So as you know, in a year from now, the final report will be published. Last week, the first public report was published. It is available on the MLEAP project page, as well as on the Airbus Protect MLEAP page. So go check it out for those who haven't seen it. So regarding event, I'll also go fast. So you should have received an email. So Airbus Protect is organizing artificial intelligence conferences and networking at Paris Air Show on June 21st. So we will have 2 conferences. So the first one will take place at the Airbus Pavilion from 10 to 11. This one is on invitations only. So if you'd like to attend, just directly send me an email. You should have all my details in the email I sent. And there will be another presentation on the same day, June 21st as well, from 3 to 5. It will be a 2-hour conference, and we will end with networking lunch like what we're going to do in a few minutes. For this one, it is an open registration. I think we have around 80 seats available, so just go to the email I sent and register through the email directly. So regarding the project, I already talked about the report, and so there will be a few more events before the end of this MLIP project. So the next Stakeholders Day, the 3rd day, will take place in January 2024, and as well as with the Awareness Session Conference. For those conferences, for now we still don't know where it will take place. Most likely here in Cologne, or maybe at the Airbus Protect facilities in Toulouse. We'll see. And so we'll have another knowledge sharing conference on April 2024, and the last Stakeholders Day, the 4th edition, will take place in May 2024, most likely same either at Toulouse or in Cologne. Okay, so as well, on the communication side, don't stay informed about everything about the MLIP project. You can find out our website, so for Airbus Protect, LNE, and Numalis, as well as the MLIP, the EASA MLIP project page. and as well as the event page for the EASA, for the Airbus Protect Artificial Intelligence Day at Paris Air Show. So last but not least, I wanted to thank all the speakers today and all the attendees for either joining physically or virtually. It was a great 2D event, and thank you so much for EASA for having us today for this great event, and maybe we can do it sometimes again. Thank you.
Thank you. Thank you, Mathieu. Yes, and from my side, closing, I have the pleasure to close this conference, this first conference on AI, so the EASA AI Days. We hope you enjoyed it. We hope we can repeat this activity regularly. We will see the pace we can give to it, but that was, I want to express my gratitude to all participants that made it to EASA this week, all participants on the WebEx as well, lots of participation. Thanks for the many questions on the Slido. And thanks to all the speakers, for the MLIP team also today to be present in such a number. That's great to see. We aggregated a lot of questions, discussions at all coffee breaks, etc. Let's continue it at the lunch that is sponsored by Airbus Protect today. Yes, many thanks from EASA side. It's a very important event for EASA, for the EASA AI program team. Thanks for coming. Safe trip back, and all the best for the next holidays coming, the two coming days. Yeah. Thank you. Thank you very much. I was about to say, let's stay a couple of minutes, if you don't mind, just to exchange on a couple of questions. It's now a bit extra conference. We can take maybe just like 5-10 minutes, see how the floor is going for questions on task.
Okay, let's do that. Okay, so we are back. Okay, so one question on the task 2. So we found very valuable table 4, sec 4822, page 181. I well understood that you plan to provide example in MLIP report how to apply those metrics for the use cases. Do you confirm my understanding?
Yes, of course, this is the objective of the evaluation part for the task 2. And on the table of this section, we have made a pre-selection of the methods as explained by Jean-Baptiste based on the genericity and the applicability of those methods for the main use cases. And on the upcoming steps, we will put into evaluation and empirical step of these methods.
Okay, another question for task 2. So how do you compute the generalization bound for computer vision models? If the input data is an image, what is used to estimate the generalization bound? Is it only an error matrix?
Generalization bound is not only an error metric, so we have the functions to compute the error of a model, which means that how many wrong outputs made by the model. So if it is a vision application, so we have images as input, and we are trying to make a model that correctly classifies something. So how many times my model make a mistake? This is the error. However, concerning the generalization bound, this is something else. There is different models to compute or to estimate the ability of the model to generalize well after the training, and this is something else different. So we have provided on the table from the same section a set of methods that can be applied for different kinds of neural networks, so you can check there to find the methods that correspond to image processing.
Yeah, if I may. Concerning the generalization bounds, effectively, depending on the architecture, the frameworks you are using, you can quickly have a vacuous bounds, meaning that you cannot say anything with this calculation. Nevertheless, what we have done is especially selecting several bounds applicable in many different architectures, depending of the group of symmetry you could have within your data. Then it will be the part of the experimentation to provide the feedback feedback. Okay, this bounds is easy to calculate and provide good result, or we can forget it for this kind of applications.
Okay, so there is 2 more questions, and then we'll end the conference. So, in evaluating the state of the art, do you conclude that present methods to generate generation bounds on the intended ODD are sufficient to assure the performance of machine learning for some functions, not necessarily safety critical?
So concerning the selected methods, the pre-selection process is based on the analysis of how the metric is developed and how this can be applied for which kind of models and data. So concerning the ODD, so this maybe we will have more concrete answers during the evaluation process of these selected methods. But currently, the selection process is based on a first analysis. So maybe, Jean-Baptiste, you can add something concerning the applicability of for the use cases.
So, yeah, this was the main driver to have the bounds applicable to the different use cases. Nevertheless, as we are discussing the ODD concern, of course, it is key to know what we are doing for which purpose, and there is some limitation concerning the guarantee we can provide. Nevertheless, I think we should not stop if we don't provide 100% guarantees, but continue to say, okay, with this kind of bounds, we can achieve this kind of requirements answers, and we have a remaining gap, and maybe it will be the objective of a further project to develop new approach closing those gaps, but at least we know where we have some discrepancy between what we expect and what we can do.
Okay, so we have 1 question for task 3. Can you comment on the applicability of formal statistical empirical methods versus dimensionality of the models and the input space?
Right, so 2 questions there. So input space, dimension of the input space, and dimension of the machine learning model itself. Basically, statistical methods is good to explore far away, but you only have a very partial view since you only have data points. Formal methods are good to explore locally, even if high dimensions. You can explore in many dimensions, but you cannot explore from minus infinity to plus infinity at once, obviously. So the trade-off here is that you can do it at that. When you do statistical analysis, it's like you're tossing a lot of stones in a lake, so you have plenty of hitting points, and then formal methods, you can have the ripples that explore around where the stone has landed. So this is where the combination can be used even if you have a high dimension input space. In terms of dimensionality of the model itself, basically statistical methods have no issues there because you have to run the model, so we assume that your model can be run, otherwise it doesn't make much sense. For formal methods though, there is a challenge there. Originally, the academic tools were focusing on quite small models in order to make proof of concept that it's applicable. What we can say is that more and more the applicability and scalability of formal methods and formal tools based on formal methods is growing. And so even if right now ChatGPT might not be processed by formal methods because it's rather large and rather new, nothing says that it will never be the case in the future. So it's still an ongoing challenge, and I'm quite optimistic for the future for the fact that even large model could be processed, because already today we can process models with dozens of millions of parameters with formal methods, which are kind of already good models for industrial use. You don't have to always have billions of parameters. You can do a lot with already millions of parameters. So I guess that there is some good performances to be obtained in the future regarding this regard.
Okay, so the last question, where does generalization start and end in your view? What can be addressed first then? There seem to be quite a few approaches that generalize locally, for example, time limited to seconds and without the need for global generalization, example, all the time.
Yes, concerning the generalization evaluation, in fact, there is different aspects to evaluate how the model can be performant after its training. So there is this concept of local generalization concerning the sub-components of the input data set, but there is also the local robustness, so I will let Arnaud explain after. And also, we need to evaluate the global generalization, which means that based on the whole sample of an input data set, without splitting it into sub-parts, we need to evaluate how this model is performant in terms of correctly predicting the target class, for example, or the target score. And concerning the local and the global robustness, Arnaud, you can add more.
Well, global robustness, it's still not achievable right now, or at least for the state of the art of the AI system, and not just very specific AI system that you can do it on them. But in generally speaking, it's not achievable yet. I hope that also the state of the art can improve on that, but it's not already there. In local robustness, in contrary, is quite available and affordable in terms of processing power. So on that regard, that can be achieved.
So thank you. That was the last question. Thanks for your patience to stay a bit longer. I think it was really good to engage in the last questions that were available. So thanks again, everyone, for participation online. Let's continue the discussion here on site around the lunch, and thanks again all for coming. Thank you.